So here I have two files, which is the train and save, and then we have our testing. So for the train file, just go up. We start by importing our data set or adding it in. So we have, first of all, we have in our data set, we have here, we have train, which has man and woman. And then we have our test, which we'll be using as a validation. So let's go back into train and save. So we have our training directory, which is dataset/train, and we have our validation directory. And then we'll have the train man, train woman, validation woman, just to make sure everything is running smoothly. And then we have the f names is just file names. We use it by using a list directory. And then we do the same thing for man, and we do it for female. So here are the just 10 files, just to make sure that we are in the right directory. So then we are here. We will start building our model now. This is our input layer, which we discussed before, and then our 3 hidden layers. And then we flattened our model as we discussed, and then we added our dense layer, which connects everything together, and we added our output layer. Then here we can just compile the whole model together, just to be sure, not to be sure, just to get everything into one model. And then here we have our model summary, which, as we discussed before, we have our input layer, which takes input of 150 by 150. And then we have our first 2D layer, which takes that input and gives out that output. So as we were saying, the max pooling, its most job here is to instead of dealing with 148 nodes, we are just dealing by 74 nodes, or neurons, sorry, which are coming out from a 16 node and 16 node. So here we take these 60 nodes, we turn them into 32 nodes into the other into the next layer, the next const2D layer. Then we have here 72, it also turns it into 36, and so on. And then at the end we have our output layer. So now all we left to do is just compile our code by using the loss function binary cross entropy, since we are just doing binary classification. And we were using matrix accuracy. And then here we will just using data augmentation. So we generate from each and every image, we generate multiple images with different scales. So instead of having just 800 training images, we can just end up by more. So this is what happens when you run your Face ID on your phone. They just take one picture of yours and they generate multiple images of it. So they get better accuracy each and every time. So here we have the train generator. We are just turning all of the images into our target size, size 150 by 150, and we are specifying the batch size, which is 30. So the model will be learning on 30 image, 30 image, 30 image, 30 image. And our class mode is binary classification, right? So we have a validation generator, which we use the same thing, but instead for us now we don't need any rescaling. Sorry. Oh yeah, we'll be rescaling it so we end up with more images for each and every class. So here we start training our model, and we can here I just trained for 10 epochs because and this is just for illustration. There's no need to make anything fancy. So yeah, and then we will start plotting. Should look something like that. And our loss, training loss and validation loss, and then we save our model. So let's run the whole code together and see the output of each and every one. And restart and run all. So basically from here on, it will be just training the model, and then it would save it here. So instead of waiting 10 to 15 minutes, I already have the model saved here, where we can just restart and run the whole thing. So here, what I'm doing is just importing those libraries. Load image is to take an image name and load an image our into our system. And then we have image to array, which extracts all of the picture of the image and puts it into an array. Load image is imported twice, both of them. Okay, anyways, we have load image here. Sorry, load model, where we can just specify where our model is located. For me, my model is located in a folder named model, and then have my model. So all of this are stuff that generated after we run the model.save. So I saved it in a directory called my model. That's why here I'm just loading it from my model. So I just generated a function that takes an image and turns it into 150 by 150, which is our input size for our model. And then we have the image to array, which turns it into an array, as we said earlier. And then we have to turn the image to specify that the image is it has 3 channels and it's just one singular file. And then we get the center pixel, and then we return it. We return it here. So here where we start going through our home directory, which is here, where I have saved all of our 16 images. here I have 8 man images, and then another 8 for woman images. And from here, we'll just check if the last 3 characters of the file name is JPG, which is the extension, then that's an image. Then we should load it into into this function, and from this function, we can just predict our image, the prediction. We can just get the prediction of our model. So if the prediction is equal to 0, then it's a man, else it's a woman. So we can just run that. So if we come back here, we have all these images of men, and we have those images of women. Sorry for interruption. So each and every one, all of the images named man are men images, and vice versa. So here we have man. We have it. The model predicted man for the first 8 images, which are men. The model predicted man, and for the other 8, the model predicted woman. So I was hoping this can finish by the time we finish, but okay. Until this finishes training, anyone has any problem, feel free to unmute and discuss. Yeah, sure. Okay. For the data set, it's found on Kaggle. I can share the link. And for the Google Colab, I think I will. Or I can just send it in the description right now. Yeah. So what is the minimum number of images we need per category? Actually, this is up to you, but the more you have, the better quality of a model you can get. So if you, let's say you have just 10 pictures, it will not be as good as you are training it with 100 pictures. So the more pictures you have, the more accurate that your model is going to be, right? And does the resolution or quality of an image matter? Obviously, yeah, because if you are using bad quality images and then you are using that model on HD camera, then for the model, he only knows the bad quality images. So usually uh, what I used to do for my other project is collect the data using the exact camera of the system that we'll be using. Like usually for uh, just for a project, like a university project or or laptop camera, just to take some pictures. Let's say you are doing Face ID. So you take some pictures of yourself using your camera, the same camera that you are going to run the code on later on. So you will get better results. So why do we need to remove redundant data from the data set? So because redundant data can cause confusion, right? So just imagine you are teaching a kid, we are doing this in these steps, but you are giving the kid a lot of information, a lot of wrong information. Not wrong, wouldn't say wrong, say like confusing data. So if you start training it with just pure confusing data, it will be super confused. So what is usually done, you can you train the data on just data set. That's what I did here. Just had some clear data set. That's why it's just predicting. Our accuracy is just around 90%, I guess, if I'm not wrong. Let's go back here and check. Mm, yeah, our validation accuracy is around 90%, just using just super clear data set, so it doesn't know how to differentiate between them. So what you can do is just train your model, sorry, on clear data set, and then you get the confusing images or and then you classify it yourself and then put it in. Then it can start predicting more confusing data set. So how you can do this, you can always retrain your model. After your model is trained, you can always improve it and retrain it, so that that's always a better solution. So what happens if you already trained your data on your model on noisy data? So yeah, as I said, you can always retrain it. So why create confusion and then fix it? That's the point. You can just straight off train your model on clean data set. That would be easier. And we have a question from Ibrahim. Okay. So is it possible to train an object detection model using unsupervised learning, as in train would be with unlabeled data? So is it possible? I'm not sure, not going to lie, but why when you can just learn, like teach it with a labeled data set? Because you can find tons and tons of data sets that are found all over the internet where you can just train it on it using it. So there would be no point of just training it on unsupervised data set. Or what do you think? It's kind of hard to label data if it's too big. So what you can do is you can just make a model that labels everything, not but you can just train it on small data set and then use supervise the beginning of it. It's supervised, completely supervised. So let's say you're just classifying tables and cups and human beings. So you just label, let's say, 50 pictures of, and then 50 pictures of table, 50 pictures of cups. And then it wouldn't be that hard if you just labeling them. And then you use that model to label the rest of the data set. So let's say you have 500 picture data set. So you can use that model that you trained. It wouldn't be that accurate, yeah, I know, but it might not recognize all of them, but it will make your work a lot easier. And then you can retrain your model with uh, with the objects or the pictures that your model has added into your folder. Retrain it, use that folder as your new data set, and keep going until you get the the right accuracy, I guess, or the favored one. So that answer your question? Okay, anyone else has any other question? Okay, so actually I wanted to do this at the beginning of the seminar, but I got dragged into it. I don't know why. So I would like to ask each and everyone, not each and everyone, but like 4 or 5 of you guys, what do you guys, what did you guys want in this seminar, but you didn't find it, and what did you want and you guys found it? If you can just unmute yourselves and say it. Anyone? Don't have to be shy.
por favor, mas se tivesse um sinal do sexto.
Okay, guess no one had any expectations. So let's go back and check on our model. So still training in the ninth. Okay. So start until finish training. There is one thing I needed to highlight here is at the beginning we start with a pretty high loss, and as we going down it starts reducing. So as long as this number is going down, you know that you are going in the right direction. Don't pay much attention to the accuracy. It goes up and down. It doesn't have to be a straight line up, but usually it will be something around that. Sometimes it goes down and goes up. So yeah, just don't worry about it. Now we will be by our last epoch here. Come on. So now, as we can see here, it stopped training, finished training, I mean. And we started with a loss of 1.04. Now we ended by 0.07. So that's a good indicator. And we started with accuracy of 0.6 and ended by 97 of training accuracy and validation accuracy of 91.47. So just waiting for it to plot the graphs for us. So yeah, our training accuracy is here is in red, and training loss is also in red. So our training accuracy started going up, just not in a straight line, but as long as it's not going so far down, we are in a good position. And then we have our validation accuracy. We had a huge drop in here, but then we recovered and started going back up. Then we have the training loss, which is the red curve also. As long as it's going down, we are in, yeah, as long as it's going down, we are in a good shape. And training loss just goes up and down. That just happens normally. And then here we have saved our model, and we can test it again here just to make sure everything is all right. So we load our model. It's loaded. Now we can start testing again. So here it has just an error, which is expected in each and every machine learning model, because there's no 100% accuracy. So here, man detected as a man. There is another man detected as a woman. Man is detected as a man detected as a man. There is another man here detected as a woman. And the rest are pretty much right. So let's go and see which ones detected wrong. We have man 7 and we have man 2. Let's come here. Man 2, have man 7. So we have this picture, got it confused. And we have that picture that got it confused. I don't know why, but okay. So that's pretty much it. Anyone has any questions or anything, just feel free to write in the chat box. How do I increase the accuracy of the model apart from training it with a larger data set? So you can use a slower learning rate. Here for us, we used a learning rate of 0.001, I guess, if I'm not mistaken. Let's go up. Yeah, we have used 0.001, which is a pretty high rate for a model that would be used in industry. And then also you can play around with your algorithm, which is here we're using CNN. Some use some other different algorithms. Depends from a data set to another data set, which just play around with it until you find out your most your highest accuracy model. And then also you play around with your activation functions. So each an activation function, it has its own way of doing stuff. So just try some bunch of them. You can just have them in an array and automate the whole thing. That would make your work whole a lot easier. And also we have, yeah, our batch size. So our batch size is the amount of pictures, sorry, that the model compare each to each other. So let's say here I'm using 30 pictures. So the model is just focusing on 30 pictures and redoing until it's done with the whole data set, right? So we can just turn it into 50, 60, 70. The more you increase it, the more pictures the model can learn and get more features out of them. But again, you are in a higher risk on causing overfitting. So you can just play around with those numbers until you find the most desired uh, accuracy, I guess, or the highest accuracy you can get. I hope this answers your question. Okay, great. We have, can I train the model to detect multiple objects and the number of objects in an image? Actually, yeah, you don't train it to do this. I had another model that I had run before. It's for face mask detection. So what it does, it just usually when you are dealing with faces, you run something called CV. So that CV is just you sorry, CV dot detect face, if I'm not mistaken. So you go through this. Let's go through it together. Just go here. Can you all see the code now, or it's unclear? The font, all right? Yes, no, anything? Okay, good. So what I used, this project I had it almost a year ago or something. I'm pretty sure there's something new now, but that's what I that was available that year when I did it. So we have something called CV2. That CV2, it has where is it? Yeah, function called CV dot detect face. So it detects each and every face in the inside that frame, and then you can just enumerate or just loop in all of the faces that you have found. And with that face, you just feed it into, where is it? Where is it? Yeah, you feed it into your model, and then you can print the confidence. How sure are you if that person is wearing a mask or not? In that case, I mean. So we can it can detect as many faces as you can fit in a frame. So yeah, you can, from there, I think you can just print the number of faces, like faces dot length or something, or length of faces here. It will print the amount of faces in here, and then for each and every one, for each and every face, you can keep a counter, like, yeah, males is equal to 0 here before you start looping. It can be like males is equal to 0, females are equal to 0, and then each and every male and female pops up. You can just increase it. So yeah, so just to get an idea how it looks something like that. Just not wearing a mask, then you put your mask on, it's 99% wearing a mask. So yeah, that be pretty much it. So is it possible to deploy the model via Streamlit or Flask? So as far as I know, TensorFlow libraries are pretty much available in most of the languages. So you can just look around how you can do it in that specific language. For example, let's just go through it together, I guess. Let's go. Keras load model task. So yeah, here you just can import the libraries, and that would be much it. Just it would differ from Python to Flask to whatever programming language you're using, or whatever server backend you're using. It's just the matter of syntax, but yeah, that's it. So do the models always give the same result? Let's say I test it twice on the same data. If it's in the same condition, it's most likely to do. But if you're just different lighting can cause uh, different results. So just as you saw in the model we just trained, after we retrained it, there were two errors in those two pictures, which were working fine on the previous model, the one I trained before our session. So yeah, it depends from a model to it depends from a model to another. It depends from the accuracy of the model, how much the model is confused about your topic, the topic that is supposed to be solved by that model. So let's say if you have pretty high accuracy, it's most likely to give the same answer each and every time. So yeah, anyone has another question? I hope I did not ignore any question. Yep. So for those who asked questions, do you have was my answer clear enough for you guys? Anyone's facing any kind of miscommunication or something?
You did good, thank you.
Okay. So I think that would be much it. So thank you guys for coming. And there would be a form that would be sent out later around 10:20, something like that. So please give back your feedback about this event, and looking forward to see you guys in future events, inshallah. Okay, thank you so much.